record this meeting because we have a nice presentation lined up.
Cool. All right, so today is a very exciting day. This is one of my favorite machine learning topics. It is GANs, Generative Adversarial Networks. You might have heard of these or seen them. There's some really cool stuff that they can do. One of the coolest things that you can do with GANs is generate fake faces. So there's this website called thispersondoesnotexist.com, where every time you reload the page, it gives you a new image that looks like a photograph. It looks like they took a picture of somebody, but none of these are real. These people do not exist. They are completely AI generated. So they're really compelling images, and it's pretty amazing that we can do this. But yeah, these are completely fake. Another cool thing you can do is this style mixing of faces. Here's a little video. Here's this thing that people made called Style GAN 2, where you can see how they're sort of blending between different faces. And it's really fascinating to see. On the left, it's like blending between these different people. And then on the right, it's like combining two images, the style of one and the face of another. Really impressive stuff that if you tried to code this by hand would be all but impossible. You can also do text to image translation, which is sort of magic, where you just describe in words what you want. So you say you want a red bird or a blue bird, and it makes images of the thing that you describe, right? These are not photographs again, these are generated pictures. And it's, again, seems sort of impossible, right? And so there's all kinds of things, generally image generation, that you can do with these GANs. And the crazy question is, like, how do these work? How is this possible that you can do this? And the remarkable thing is that the answer turns out to be hilarious, which is that you actually have a battle between two different computers. So this is where, by the way, in the name Generative Adversarial Networks, this is where the adversary comes from. You have two things fighting each other, which is really wild. So you start with a data set of real images, right? These are like real photographs that you want to make a copy of, or not copy, but copy the style of. And the idea is that we want to have a generator that can create similar looking images, not the same, not exact copies, but things in the same style. So we want to have this generator, which is sort of our artist, right? That paints the new picture. But because it's adversarial, well, it needs an enemy. And the enemy of the generator is the discriminator, who is the critic. The idea is that you have this artist who's trying to create these perfect copies that are indistinguishable from the real thing, right? When you look at one of these generated faces, you shouldn't be able to tell that it's not real. The job of the discriminator is to look at two pictures and decide, oh, this one is real and this one is fake. And so you can see how having these two enemies try to beat each other, they will both make each other better, right? As the discriminator becomes better at picking up the little differences between a real image and a fake one, the generator will get better at creating convincing images. And as the generator gets better, the discriminator also has to get better. And so you have this battle of the minds that hopefully will create this incredibly talented generator. So here I'm sort of specifying exactly what the job is of each of these two enemies. The discriminator needs to identify real examples versus fake ones created by the generator. And the generator's job is to trick the discriminator into thinking that the generated examples are real. So if you've done some machine learning before, you maybe are familiar with the idea of a loss function. If not, that's okay. But the idea here is that you want to have a really clear picture of what does success look like and what does failure look like. And then once you have that, you can just tell the computer to go wild and try to be more successful. It's sort of like getting grades in school. So ultimately, we only care about the output of the generator. Like the discriminator, we don't actually need, right? We just are trying to generate these images. The only reason we need the discriminator is because he forces the generator to get good, right? It's like this competing force. Okay, so the question is, if we want these two people to sort of battle each other out, how does that actually work? What does the process look like of actually training a GAN? First of all, I want to stop. This is something I haven't done a good job of before. I want to ask if anyone has questions so far. I think it would be good to just check in and see, is there anything that doesn't make sense about this before we actually try to see how the training works? Silence. Either you're terrified or you have no questions. And I don't know which it is. You got a question?
So what makes the so that the generator doesn't just copy it?
That's a really good question. What we're going to find out later on is that we sort of feed the generator some TV static as like random input, and it has to create its output based on the random static that we give it as input, which forces it to create something new every time. It is still possible that it sort of learns just how to create one particular image. And so there are techniques that people use to avoid that. But that is beyond the scope of what we have to do today. Fortunately, the thing we're doing is simple enough that this doesn't really become a problem. But that's a really good question. Anything else before we go on to training? All right, cool. So we want to have these two things battle it out and make each other better. And the question is, how does that work? So we have our generator and we have our discriminator. And the first thing we want to do is create some generated samples, right? We want the generator to make some images. And at the beginning, the generator is going to be terrible, right? Because at the beginning, the generator is essentially just going to paint random garbage because it doesn't know anything. And that's okay. Over time, it'll get better. But we want it to create some generated samples to the best of its ability. But as we just mentioned, you actually need to give it some random input first to sort of force it to do something new every time. And so that's exactly what we do. We take what looks like TV static, which is essentially just a random image with random pixel values, and we feed it in, and then the generator uses that to sort of morph the input into some kind of output. It's useful to think of every sort of neural network model as a function that takes an input and an output, like in math class. And because the generator is a function, the way we get it to give lots of different outputs is by giving lots of different inputs. So in our code, we'll just make random static images and feed them in. So the generator now has made a bunch of examples. And then we want to get some real samples as well. And this is how we're going to give the discriminator a little test to see, can it tell the difference? So we go to our training example set. This is our big data set that we started with of like things that we're trying to copy. And we just pull out some of them, right? And generally, we're going to sort of pick out 6, or in the case of today, we'll pick out 32 at a time. And we'll do things in batches. So we'll take a batch. Here in my picture, I have 6 generated samples and 6 real samples. And we take those images and we pass them to the discriminator. And we give the discriminator a little test, right? It's like when you're in class and you got to take a test. The discriminator needs to mark sort of true or false for each example. Is this a real example or is this a generated example? The discriminator is going to do its best. At the beginning, it will essentially be totally random too. Just like the generator, it doesn't know anything at the beginning. And so it'll give its output. Here's what I think the result is. So at the beginning, they both don't know anything. But after they look at the result that the discriminator gave, you can sort of compare the discriminator's responses to an answer key of like, here's actually which ones were real and which ones were generated. And the discriminator looks at the grade that it gets back, and it says, oh, I was wrong on these 3, but I was right on all the others. And then it tries to learn from that. And this is the idea of backpropagation. The nice thing today is this Python library PyTorch will do the backpropagation for us. So we don't really have to worry about the ins and outs of how that works. But essentially, the idea is that the discriminator is going to look at its test score and go, what did I do wrong? Right? It's going to analyze itself and go, how could I have given better results? And that's what it'll do. And it'll improve itself very slightly. The generator can also improve itself using the discriminator's test results. Because the generator says, okay, all the generated images, I hope that the discriminator got it wrong. Right? I hope that all the ones that were generated, the discriminator thinks that they're real. And if that doesn't happen, then I, the generator, have something to learn as well. So this is sort of the learning process for the generator and the discriminator. That was a lot to take in. So again, I'll stop and maybe ask for questions. Is there anything here that doesn't make sense or that feels weird? No? Again, silence. I don't know what it means. Could be good, could be bad. Okay, I think we're good. I'm getting thumbs up. So this is the basic idea of how these two things battle it out. We do this process over and over and over again. So this is just like one step. We do that hundreds, thousands, even if you're doing something impressive, maybe tens of thousands or millions of times. And you just do this process over and over again. And the generator and the discriminator both get more and more talented. And eventually your generator is really good. And now you're able to generate these fake images. So then the question is, what are we building today, right? It's great to look at these fake faces and stuff. Unfortunately, training something really impressive takes a lot of time, not even a lot of programming time necessarily, but a lot of time just sitting and waiting for the computer to think, right? These two, generator and discriminator, they learn very slowly. They're slow learners, and it takes a long time and a lot of computing power to get through it. And so unfortunately, we have to dial back our ambitions a little bit. So instead of this beautiful Bob Ross painting fake faces, what we're doing today, just for the sake of learning time, is we're going to try to get a generator that can take random points in space as input, like two-dimensional points, x, y coordinates, and produce points on the sine wave as output, which is kind of interesting, right? It's like, it sort of feels like a totally different problem than generating images. It feels like that's a totally new thing. But it's actually the same idea, which is, can you take random noise as input and produce a certain kind of result as output? So this is what we're trying to do. And then we'll have a discriminator that can hopefully tell, is a point on the sine wave or not? So this is kind of a letdown as a, it's like hype it up as, okay, we're generating images, and then all of a sudden, no, we're generating a sine wave. Boo-hoo, so sad. Fortunately, at the bottom of the notebook where you'll be doing your work today, I did include another thing that actually does generate images. The only reason we can't do this during the hour today is because it takes like 45 minutes just to run the training code, right? And so I don't want all of us sitting here for 45 minutes waiting for it to train. But if you get all the main ideas from today, where we're generating this sine wave of points, you will actually know exactly how to do this image generation where you're sort of creating these handwritten digits, essentially teaching the computer how to write. And so I highly recommend all of you, it doesn't even take a lot of your time. You just like press the run button and then go get dinner and come back, and you'll have this thing that knows how to hand draw digits. And it'll be using all the same ideas that we covered today. So that is the big idea. I want to show you the notebook here. As always, we have this little Python notebook where you can go in, and the first thing you're going to do is generate your training data. This is sort of like when we have our database of, faces that we're training on, like in the bottom left here. But you'll just be creating essentially a bunch of examples of points on the sine wave. And then once you do that, it'll walk you through the process of training this generator and discriminator. And hopefully by the end, you'll be able to generate points. And it should be really cool. So that is the plan for today. There will be a link in the Discord to this notebook. So you can open it up, and the instructions are in here. It should be fairly straightforward. But of course, if you have questions, throw up a hand. Yeah, that's the plan for today. So we'll throw the link in there and you can get started.